All right, other trig functions. We've got sine and cosine, and we'll put together a little table when we're done with this. I'm going to give you two of them, but I want to show you tangent because I think this is an interesting problem. Because the trick here, and by the way, proving stuff generally just involves applying tricks that you saw somewhere else and say, hey, I wonder if that trick would apply here. I'm going to rewrite tangent as sine divided by cosine. And now I've got a quotient rule. U is equal to sine of x. The derivative of u is cosine of x. V is equal to cosine of x, which means that the derivative of v is negative sine of x. And then the quotient rule says that this derivative is v du. So cosine times cosine minus u dv. Oh, well, that's plus sine times sine, all divided by v squared, cosine squared. Notice there's the squared that I mentioned last video. So cosine squared plus sine squared, well, the Pythagorean identity says that that's equal to 1. So this becomes 1 over cosine squared, which is secant squared. By the way, if you get confused about the inverses of sine and cosine, just remember that it's the exact opposite of what you think it should be. This is cosecant, and this is secant. That took me a while in school to remember because I was like, well, they should just go together. And then as soon as I remembered it's the exact opposite, I never had any trouble again. So the derivative of tangent is secant squared. So let's make a little chart. What have I got? Function, derivative, inverse function, derivative of inverse function, inverse function, derivative of inverse function. Oh, this is getting awkward. So what do we got? We got sine, we got cosine, we got tangent, we've got cosecant, we've got secant, and we've got, whoops, didn't mean to do that. Cotangent. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of cosecant, and I don't use these as often as I might, so I don't remember them, is negative cosecant cotangent. The derivative of secant, that's not an equals there, that's just the derivative. The derivative of secant is secant tangent. And yes, I am saying secant and cosecant in a very, very definite way so that I don't want it to sound like I'm slurring. And this is negative cosecant squared. So notice that we got some patterns here. If we look at sine and cosine, what have we got? We've got just the opposite and then the negative opposite. If we look at cosecant and secant, we've got a negative and then we've got the positive or the opposite of the other one. You have to remember one of them, cosecant, cotangent. But notice that it's self times cotangent. So cosecant is itself times cotangent. Again, just mnemonics, ways to remember. Whereas when we look down here at secant, again, we see itself times tangent, not cotangent. And then on tangent and cotangent, what we see is that secant squared and then negative cosecant squared. So sort of goes along with, let's see, secant is cosine. So this, if we think of this as sine over cosine, this goes along with the denominator. And this, of course, is cosine over sine. So then this one goes along with the denominator. Again, there are patterns is the point here. And a lot of math is patterns, so it makes it useful if you don't have to brute memorize if you think about the patterns. Okay, let's see. Let's do a quick example. And the example that we are going to do is given the function f of x equals tangent of x over x, find the equation of the tangent line at x equals 2. So what do we need for equation of a tangent line? We need a point, and our point will be 2 comma f of 2, and we need a slope, which will be f prime of 2. So first thing I can do is plug 2 into there, and what I get is that the point is at approximately 2 comma 1 negative 1.093. And finding the derivative, we're going to use the quotient rule. So I know that u is equal to tangent, du is secant squared, v is equal to x, and dv is equal to 1. So v du gives us x secant squared x minus u dv, which is just tangent of x, all divided by v squared, x squared. And then I can plug that into my calculator, and I get that this is approximately 3.433. So the equation of the tangent line, guys, for just the sake of easiness, just go straight to point slope form. Don't worry about y equals mx plus b or the y-intercept form, because you can just write this as y plus 1.093 equals 3.433 times x minus 2, and you are done. No extra calculations required. I know we're generally used to y-intercept form, but this is so much easier. And if we take a quick look at the graph, jumping into our calculator, what we see is that this function looks like this. Crazy weird function. And x equals 2 is right about here. So there's my point. And here, if I graph the tangent line in my calculator, it hits right there. So, in fact, you can see that that is a tangent line to that point. Okay. If you're in my class, go ahead and do exercise 23 in the book, and we'll be back with one more example and then a recap.